Hello and welcome everyone to Mastering Security Requirements Engineering here at the sec4dev. My name is Thomas and I've been working in the field of information security for over 20 years by now. I'm currently employed at SecConsult, working as a team leader and as a principal security consultant. In the beginning of my career, I did a lot of penetration tests and security source code reviews. Over time, I decided to go more on the defensive side, and so I spent many years working in secure software development as a security architect and as a security requirements engineer. Today, I want to share my experience in security requirements engineering with you. So what's on the menu? First of all, I want to give you a quick introduction into OWASP SAMM, one of the flagship projects of OWASP, the Open Web Application Security Project. Then we will dig deeper into security requirements engineering, talk about the fundamentals, but also how to reach mastery. In addition, I want to share with you what the typical pitfalls are when you start out with security requirements engineering so that you can avoid them up front. And in the end, we will also discuss how to ensure a proper security posture and which steps to take if you want to improve your secure software development processes, including security requirements engineering. OWASP SAMM version 2 was released last year in January, almost 1 year ago. It introduced many new activities, especially concerning DevOps. The goal of OWASP SAMM is to show you the current maturity level of your security activities when it comes to secure software development, but also to give you a roadmap how to improve your practices so you can reach the desired maturity level. Let's take a look at the individual areas of OWASP SAMM. It is split into 5 areas. They are called business functions. So we have governance, we have design, we have implementation, we have verification, we have operations. Governance is mainly concerned with the secure software development lifecycle itself, how to ensure compliance, and how to get the right people for the right job. Security design, our main topic for today, focuses on threat assessment, security requirements engineering, and also security architecture. When we are entering the area of implementation, we are talking mainly about building and deploying your applications in a secure fashion and also managing your defects well. Verification is all about testing your application on architectural level, but also requirements-driven testing and specific deep dives in the areas where it's required. And OWASP SAMM also covers operations, all the security activities necessary once the application has gone live. But today our focus is on the design phase and specifically on the second area, security requirements engineering, the software requirements, but also the supplier security requirements. If you want to know more about the different aspects of OWASP SAMM, I highly recommend checking out an article I wrote for Heise Developer. You will find the link at the end of the presentation in the slide set as well. There I will go into all the different areas of OWASP SAMM so you can get a good overview what's in there. But when we take a closer look at security requirements engineering, we will see that it's just one of 15 different activities, so is it really that important? On paper it just looks like one out of 15 activities, but in reality it's the foundation for most of those activities. So basically many of those activities refer back to our security requirements, and without proper security requirements those activities would be without proper orientation. Let's take a look at some examples. I brought some examples with me to illustrate this point. First of all, we have a direct influence on security architecture. Security requirements define what the application should do, not how it should do it. The how is defined by the security architect. So the security architect needs the initial guidance by the security requirements to know in which areas he has to define security controls and what he must guarantee with his architecture. One very specific example would be looking specifically at secret management. When you have to manage secrets in your application, that's a typical scenario. You know secrets like user credentials and so on. You can store them in a secure fashion using advanced hashing algorithms and stuff like this. But when it comes to storing actually secrets that you need to use, like credentials for a database, for example, you can't store them as a hash. So you have to access them at one point in time. You need them in plain text, otherwise you can't use them. So there are different ways to do this. For example, you can protect them in configuration files. You can use some external service to provide those credentials. You can have a specific microservice architecture that allows you to access those credentials. You can also implement this as an HSM, as a hardware security module, where your certificates or your cryptographic keys are stored. What's the right way to do it? Which implementation is the correct one? Well, all of them can be correct. It highly depends on the protection profile of the application and specifically on the security requirements for this application. So when I am designing the secret management implementation, I will have to look at the actual security requirements. Otherwise, I'm just guessing what I have to do. And of course, you can get together in your team and discuss what's the right way. But in a perfect world, this would already be designed in the security requirements. Requirements-driven testing, it's already in the name. We want to have security requirements tested specifically. This is a new introduction, version 2 of OWASP SAMM, and I'm very glad they decided to do this. Because what I've seen in practice is that we do generic penetration tests, generic code reviews, without focusing on the main areas that are really important, because often security requirements aren't properly specified or are not passed on to the test team. We also see a direct correlation or a direct impact from security requirements in environment management. Specifically, let's assume the scenario you want to install a new security patch on your application. So the question is, how long do you want to test before you install this patch? Because the patch could break something. On the other hand, well, if you don't install the patch right away and the vulnerability gets exploited, you could face a serious compromise of your application. So installing them rather early would seem to be advised. What's the correct way to go? How long and how carefully do you want to test the patch before you install it? Again, I can't tell you the answer straight away. This should be defined in the security requirements. Do we have security requirements that really put the focus on the availability? In this case, it would make sense to test the patch more in depth and take more time to really verify that the availability of the application is not affected. But on the other hand, if availability is not so crucial, but you really want to protect the confidentiality and the integrity of your data in the application, in this specific case, you want to install the patch rather earlier than later. So again, taking a look at the security requirements concerning those specific protection targets is necessary to define how this process should be implemented. And last but not least, we also have effect in the governance area. Just one example, training and education. If you don't specify in detail what you want from a security perspective in your application, in your security requirements, chances are that the development team, the architects and so on will miss some of those points. You might assume that denial of service prevention is standard, that's normal, we don't have to define this. But if you don't define it, and the architect and the developers and even the test team is not really aware that that's a requirement, well, what will happen? Chances are that these topics are overlooked and there might be issues in production when we have our first denial of service attack that actually go through and impacts our application because no one addressed this topic. On the other hand, if you would have specified it in the security requirements and some developers or architects realize we are not really well versed in denial of service protection, we don't know how to really do this, we might need some proper training for this or some internal workshop where someone can brief us on how to implement and design such security controls. In this case, someone would have raised their hands and said, well, can we have some training? We are not really sure how to do this. If that's not in the security requirements, chances are no one will raise their hands for something they are not even really aware about that this is required. So your security requirements can actually help guide your education activities as well. As you have seen, security requirements engineering is really important for many different security activities. So how should you define your security requirements? First of all, requirements engineering is an established craft. We have done this for many years, even decades, and we know what's important when we engineer our requirements. Only when it comes to security requirements, people get a little nervous and are not so really sure how to do it. It's interesting, but we can apply all those fundamentals that we have learned with requirements engineering also for our security requirements, and we will have success doing so. So first of all, you should implement for full integration. It's a mistake to assume that security requirements are anywhere in any regard different than other requirements. You should basically not even be able to distinguish between your security requirements and performance requirements or usability requirements or just functional requirements and so on. It's fine to tag them. It's not forbidden to show that those are security requirements, but there shouldn't be a separate security requirements document. There shouldn't be a separate tool to manage them. They should be integrated in your overall development processes. They should feel like normal requirements because, guess what? They are normal requirements. So, as I've said before, they should define what to do and not how to do it. That's important. If you go too much into the how in the technological aspects and in the security pattern aspects already during your requirements engineering process, you basically take the tools out of the hand of the security architects, and this will lead to trouble down the road. So stick to the what and let the how be implemented by the security architect. You must be specific. It doesn't make sense to have some overly generic, broad security requirement. Like with every other requirement, make it specific. And also make it measurable. If you cannot test it, then it's definitely not a good requirement. And of course, it should be reasonable. I have heard and led many discussions about different security requirements and do we really need them, and it is more than helpful to document your reasoning behind this, why you need it, not only to argue for those requirements, but also if you decide to change something later on and you have to go back and decide, is this requirement still necessary? Can we implement it in some other way? And if you have this reasoning, you can tell if those alternative implementations would work as well. So if you're totally new to security requirements engineering, you might be a little bit lost now. Where do you actually start? And I can give you one shortcut, and please be aware and be warned, that's really just a shortcut and this won't work for you in the long run. But to get some initial security requirements more on the technical side, you can check out the ASVS, the Application Security Verification Standard from OWASP. It's a great standard. It defines specific test cases that should be performed for different types of applications. So how does this actually work? You take a verification requirement. For example, you want to verify that files that are uploaded to your applications are free of malware. So you have to verify this by, for example, uploading malware and see if the application protects against this. So if there is a mechanism in place, this has to be designed somewhere in time and also needs to be implemented. Otherwise, it would not be testable. So there is your requirement. You have to specify this functionality. And as I said, this just isolates some specific technical areas and especially some vulnerability classes, but it's a great way to get your initial security requirements, experiment with them, and work from there on and broaden the focus, bring business requirements in there, bring compliance requirements in there, bring domain-specific knowledge in there later on. But here at this moment, you have a good starting point you can work on. just important, don't stay at this stage, otherwise, yeah, you will miss out a lot of opportunities. If you want to be successful with security requirements engineering, you must ensure proper verification of the implementation of your requirements. Sounds obvious, but I'm basically not an advocate of strictly right from the start integrating security requirements straight in all your different security activities. I'd rather prefer to go over the verification route. So basically instilling the mindset in the head of every developer that security requirements are not optional. Sounds a little bit strange for me to say this because requirements usually are not optional. They are requirements, they are mandatory. So in practice, I see way too often that security requirements are treated optional for whatever reason. And once this mindset is instilled in the developer's head, well, it's hard to get out there. So right from the get-go, you should make sure that those requirements are properly verified. And if the verification process fails or basically shows that security requirements are not properly implemented, this should basically break the build and make sure that the application cannot go live as long as critical security requirements are not fulfilled. If that's the mindset that's present in the developer's head, that security requirements, like all the other requirements, are mandatory, your security requirements will be treated with much more respect than the other way around. So the sooner you can ensure that verification is in place, the better. How you want to do this verification is up to you. It depends on your culture, it depends on your organization. One way to do this, for example, would be review sessions across departments. A little bit similar to threat modeling, where you get a different group of people together, developers, architects, requirements engineers, maybe someone from the security test team, maybe someone from security operation. Depending on the application, it might also make sense to get the ISO on board, and you know who's really important for your security decisions. So, and this group can discuss the current state of the application and the implementation of the security requirements and decide if the current state is okay. So basically workshop-based evaluation. You can also do requirements-driven security testing. As I've mentioned before, very important that you have specific test cases for your security requirements, and you basically can see which of those tests pass and which of those tests fail and decide if you want to go live with an application. Or you can have several quality gates where security checks are integrated. In the end, it's up to you, whatever works for your organization. Again, don't build something specifically for the security requirements. Do it the same way you do it with other requirements as well, so it feels seamlessly integrated and is easy to accept that we have some new practice here that we want to follow from now on. What I've seen in practice is that there are several mistakes that are made over and over again. Classical pitfalls that hinder your progress when you want to implement security requirements engineering. And I want to share those mistakes with you so that you can avoid them in your own projects. One of the most common ones is relying on the prevention of specific vulnerabilities. Don't get me wrong, that's important, and focusing on some vulnerability classes and really make sure that they are not present in your applications, that's key for security. But only relying on those puts the spotlight on an important area but misses a lot of other aspects of security requirements engineering. So what I've prepared for you is a little graph. You see here on the x-axis the level of competence, and you also see on the y-axis the confidence that you have in your competence. So we get this little curve. You might have seen this before. It's called the Dunning Kruger effect, named after Dunning and Kruger. It can be witnessed in many different disciplines, in sports, in music, and so on. I've seen it quite often when playing poker and new players start to play their first hands. And after their first few wins, they are really confident and think they have mastered poker and know everything that there's to know about poker. And it takes some time until they realize, oh, it's not so easy and I'm losing more money than I'm actually winning. And after they got through the first dip of despair, so to speak, they really start learning and grow better and better players and really master the discipline of poker. And we can see the same in security requirements engineering. First, when you start out and maybe you ask Google or some security aware colleague where you should start out, well, they probably will point you to something like the OWASP Top 10 or the ASVS like I did just a few minutes ago. And those standards are great, especially the OWASP Top 10 are one of the basic standards that everyone should know about, specifying the 10 most important security vulnerability classes that are currently out there for web applications. So if you're able to prevent those 10 vulnerability classes, will your application be sufficiently secure? Probably not, because there are many other vulnerability classes, there are many domain-specific aspects, there you have also the topic of compliance, of data protections, and many more that are definitely not covered in those technical standards. So what you will realize over time that you need a more holistic approach to your security requirements engineering process. As I've discussed before, you will have to specify your security requirements in a way that they are really specific, measurable, and also reasonable. You will also need to verify the implementation. We've also talked about this. It's really important, and that's what brings you on the road to mastery, to consider domain-specific knowledge. There are many different domains and different organizations with different types of requirements and compliance requirements as well. So digging deeper into them is key to get the most out of your security requirements. When you have specified your security requirements over and over again, you will realize after some time that some of those tasks are repetitive and some of those tasks could be more standardized. That's usually the point when you realize that you should establish a security requirements framework. Security requirements frameworks consists of specific security requirements that appear over and over again in your organization, already fine-tuned to your specific needs, but also provides proper guidance how to create new security requirements and how to make building blocks out of them so that you can reuse them in later projects. So basically getting really efficient with security requirements engineering. And after you have done this, and most of your security requirements actively refer back to your security requirements, and it's more or less automatic that whenever a question arises, what does the application have to do in this regard, that the first place to look are your security requirements, and in the best case, most of the time those aspects will be covered there already. So you basically don't just specify some security requirements and implement them, but you really feel that security requirement engineering has become the backbone of your secure software development lifecycle. The second pitfall I want to talk about is hiding your security requirements from your penetration testers. This one is really dear to me because I've seen it in practice way too often. What you want to do when performing a security penetration test or security code review, you want to be really efficient because you don't have unlimited amount of resources, time, persons, and so on. You really must be specific, you really must be focused on the most important areas. And where are they defined? In your security requirements. So the test team must make sure that they have a fine-tuned approach to that's what most important to you, your crown jewels, so to speak. Otherwise, it will be a lose-lose situation that's not helpful for anyone. And I kind of understand where this problem comes from. Some organizations say, well, when we do a penetration test, we want to simulate a real hacker attack. So a real hacker doesn't have our security requirements, doesn't have our source code, doesn't have access to our system on file system level, for example. So we don't share anything except the IP address, and the penetration test team should do what they do. The problem with this approach is that what you want to do is you want to find specific vulnerabilities in your application as efficient as possible so that you can fix those problems. You don't want to simulate a real hacking attack usually. What you want to do is find vulnerabilities. And to find vulnerabilities, the more information the test team has, the better. So I highly recommend sharing those security requirements with the test team so that they can really focus their efforts where they matter most. I like to compare this scenario with a doctor's visit. When I go to the doctor and say, please do a general checkup, what will the doctor do? He has a limited amount of time for each patient. Let's say he can invest 10 minutes. So he probably will check my posture. He will check my blood pressure. He will check my heartbeat and stuff like this. Maybe even check my eyesight and some, general checkup. What I didn't tell the doctor is that I have plans to run a marathon next week. And if I run a marathon next week and the doctor only has 10 minutes to do a checkup, he will probably check some very specific things. If my cardiovascular system is fine, when running a marathon, I will put a lot of pressure on my joints, for example. So he probably will check if those are fine, and so on. And if I'm in an overall well condition to run a marathon, he will run different checks. So if I don't tell my doctor this, he will probably run checks that are not sufficient for my specific scenario. And it's the same with penetration test, code reviews, and so on, if you don't tell the test team what to look for. And the third pitfall I want to share with you is not holding vendors to the same standards as yourself. I've seen this time and time again at different organizations in the real world where they are very strict with themselves, but as soon as they buy a product from a vendor or do a development project together with a vendor, the security requirements are no longer important. They assume security is the default, and unfortunately, that's usually not the truth. You really must make sure that your security requirements are specified as part of the contract. Otherwise, it's very likely that what you are expecting, that's the default, is not implemented in the application, and this will lead to disappointment, but also specific vulnerabilities that might lead to exploits later on. You should not only specify those security requirements, it's also important to make sure to verify them. So you should also include in the contract how they are verified and what has to be done once it has been discovered that they are not met. So if a test fails, if a critical security vulnerability is found, who will be responsible for fixing this vulnerability? Without clarification in the contract, this might lead to legal fights and so on, and I don't recommend to go this route. So be specific early on when it comes to your security requirements and define what your vendors should implement when they do development projects for you. Because the attacker actually doesn't care whether the part that's broken in your application is part of your own implementation, if it has been developed in-house, if it has been developed by a third party, if it's in a library that you included from somewhere. The attacker doesn't care. And a vulnerability is a vulnerability. It doesn't matter who is responsible for this quality issue. So now you might ask yourself, what are the next steps that you can take to improve your security posture when it comes to secure software development? I highly recommend to check out some of the secure software development lifecycle standards out there. I already talked about OWASP SAMM, but there's also BSIMM, there's a document from BCI, SafeCode, and so on, just to name a few examples. But there might be some specific reason. For example, you're already processing payment card data, so you might be inclined to go in the PCI direction if you also have to be compliant with PCI DSS, for example. But if there is no such indication, I would recommend to go with OWASP SAMM. I made a lot of very positive experiences with OWASP SAMM, implemented OWASP SAMM security activities at different clients with great success. So I happily recommend this standard to you. It also includes this maturity model that allows you to identify where you are currently standing and which steps you can take, which road you should travel to get to a higher maturity level if that's your desire. So initially you should perform such a maturity level assessment, see where you are currently standing, and identify those areas where you have the most leverage to improve your security activities the most, and invest in those areas to improve your overall secure software development lifecycle. I am not a fan of a Big Bang approach. When we are talking about improving the secure software development lifecycle, we are usually talking about a whole range of different activities. Security requirements engineering is one very important activity, and I highly recommend to focus on this area early on. But there are many more that you should also address if you are lacking in those areas. So you should define a roadmap that tells you in which sequence, with which checkpoints you actually want to do the implementation. I know different organizations have different practices, and some of them like to go with the Big Bang approach. I personally have seen more success with a step-by-step approach where you implement different security activities over time. As I've said, starting with security requirements engineering is a great building block to basically have some early success stories and provide a foundation for other security activities as well. It's also important to keep track of your progress. Such implementation projects can last quite a while, can be months, maybe for big companies even years. So you should do regular re-evaluations to see where you're currently standing. And this helps you to gain further motivation to see what you have actually achieved, and this will motivate you and also your stakeholders, of course, to invest further in those activities so you can ensure that growing your maturity level over time is guaranteed. We have a pretty tight schedule here at sec4dev, and all the other great speakers deserve the opportunity to present their topics to you. So I'm about to close down this session, but before I leave, I want to give you some recommended readings along the way. I wrote an article for Heise Developer about OWASP SAMM and the different security activities. You can access it by following the link on the top right on the slide. Below you will find a link to the blog series I'm currently writing about secure software development, also based on OWASP SAMM, where I go a little bit deeper than the Heise article. And below you will find my Twitter handle @dementophobia. I'm currently quite active on Twitter, talking about information security, secure software development, other development topics, and so on. So feel free to follow me there and get in contact with me. And now it's time for our Q&A session, our Q&A live session. So ask me anything, especially about security requirements engineering. If you want to get in contact, here's my contact information as well. Write me an email, contact me on Twitter, follow me on LinkedIn. It's up to you. And now, see you in the Q&A session.